among the applications. So we have to look into how we are going to manage the resources so that it could be very adaptive and available to all the requesting users. So our ultimate aim is to serve each and every users who are requesting for application. Okay, so going one step ahead, so this how the spectrum sharing is done in millimeter wave cellular network. So actually, this millimeter wave cellular network started for a terahertz communication. So where this 5G and 6G is is taking part. So in that case, if you want to work in that, if you want to use machine learning algorithms, you can make use of the algorithm and you can work in spectrum, how the spectrum could be effectively shared in millimeter wave cellular network. So it is a very interesting topic. And you can even work for efficiency of energy efficiency, and so to optimize it. So that is very important. So when you talk about this optimization, it is not mere that you can work with a machine learning algorithm. Before that, we have to model what is the optimum thing we are looking for. Suppose, for example, if I want to optimize energy, then I have to talk about, so this energy is my objective is to optimize the energy, and then I have to work out what are the constraints needed in order to optimize this energy. So if you are able to build a mathematical model in this one, and then if you use that mathematical modeling and machine learning, and the integration of these two things will be a very good combination for research in mobile communication. Ma'am, next slide. So machine learning could be used for spectrum intelligence, spectrum sharing, spectrum access, and adaptive resource management. And not only that, suppose we want to work how to efficiently transfer the data in a crowd sensing mobile environment. So in that case also machine learning algorithms could be used. And here we have to talk about how the resources could be efficiently utilized for the data transfer. So these are some of the computer science related topics, you can say that. Going into the electronic side, so when you want to work on a physical layer, then you have to function in the modulation and coding design. So there is an adaptive modulation and coding design. For this also, you can use machine learning. And in MIMO, there is multiple input, multiple output. So that we'll be going to discuss later on. Okay, for estimation of the nonlinear MIMO detector also, we can use machine learning along with symbol detection. So these are some of the areas where you can combine machine learning and mobile communication. So people know about only the broad area, but we won't be aware of where to actually concentrate. So that is important. So for that only I have narrowed down the topic. Ma'am, next slide. So I told you, so earlier, you want to work on the physical layer, and in the adaptive modulation coding, you can do it. Or else, suppose you want to work in the physical layer location, you can do the verification by using machine learning algorithms. And suppose if you're interested in context, so in that case, you can go for context and cross-layer optimization using machine learning algorithms. Channel equalization and signal detection. So this is a very wide topic. So channel is wireless. What we mean is that, for example, assume that we are having a mobile device, and that is called as mobile station, and the base station is somewhere else. So how we are interconnected? How the mobile stations are interconnected to the base station by the air interface? No. And what is present in between? In between is the channel. So that's called a wireless channel. So this channel is an unpredictable channel, okay? But there are certain algorithms are there to predict, not to actually predict, but you can somewhat go for some assumptions. And based on the channel nature only, you can predict. Suppose if you are sending X as the input, then you receive Y as the output. So in between that, you have to set up a system, and that system is called the channel. So this will be useful before doing a practical work. So you have to do the theoretical part. In the theoretical part, you have to predict, or if you expect Y on X, then if you get Y, then the channel is perfect. Suppose if you don't get Y, when you give X, and if you get some other thing, then your channel is not perfect. So you can work in the channel. You can work in the modeling of a channel model. That is it's another. It's a little interesting as well as like bit tough topic. So that also could be done using machine learning. Okay. Next slide. So apart from channel estimation, spectrum sharing, spectrum accessing, resource management, suppose if you want to estimate the capacity of a cellular system, and if you want to estimate the coverage, actual coverage of a cellular system, and if you want to optimize that one, in that case also you can use machine learning. Okay, so that comes under coverage and capacity optimization. Suppose I have a user, and that user is a mobile user, and the mobility of the user is unpredicted. Sometimes the user may be a pedestrian user, the user may be a highly mobile user, sometimes the user may be a stationary user. And because of that, if the user is establishing a connection from a point A, where the user seems to be a pedestrian user, and assume that he is traveling to B, where I'm traveling in a car, for example, the user has transformed from a pedestrian user to a mobile user, okay, to a fast-moving user, okay, and what will be the next destination user is unpredicted. In that case, how to fairly allocate channels in a cellular system to the user so that the user service is uninterrupted. For that, you have to study about the mobility prediction, and for that we can use the machine learning algorithm. Not only that, suppose if you have the same user and the user is landing over another network called C network, then it is the main function of the C network to serve that mobile user. Suppose if the C network is unable to serve the mobile user, then what could be the problem with the C network? The main problem is the traffic of that particular network. If the traffic of the network is heavily congested, in that case, it cannot serve the visiting user. So in that case, you can predict and you can analyze what are the traffic patterns that could be available in a particular cell, and if that cell can able to accommodate such type of visiting usage. So for that case, you can make use of the machine learning algorithm. And these two decoding polar codes and channel coding. So these are purely communication related topics. Next slide now. So using machine learning, so these are some of the areas I am just highlighting, not that these are the only ones. So to me, I have read some papers and some research topics. So these seem to be very interesting, so that I am presenting here. Not only that one, you can use neural networks for signal intelligence. Then we have the information, and as I discussed earlier, even for wireless channel prediction also, you can use the neural network by modeling the entire network as a neural network. So that is also possible. Next slide now. So what is the futuristic one in mobile communication? So we discussed about the resource management, we discussed about the spectrum management, and traffic prediction, wireless channel prediction, and coverage optimization, energy optimization. All these things we are discussing. All these things are required for getting an optimized service under good operational conditions. So that will be the expectation of the users in the future. And here, when we talk about the futuristic, people are working in the heterogeneous mobile communication system. So this is a very interesting part. So heterogeneous means, for example, I have a mobile user, and there is a Wi-Fi network is there, and there is a wireless LAN network is also there. Okay, suppose if the connectivity could be integrated, or if that could be provided without any interruption on all the three networks, then we call the entire one as a heterogeneous network. So when we work in the heterogeneous networks, each and every network will have their own constraints. So we have to concentrate on those ones, and then we have to look into that in order to get an optimized service. So one of the very popular areas for the heterogeneous and the futuristic one is SDN, software defined radio networks. So these networks can be used to deploy both access networks and core networks, okay, to get a optimized service. Okay, so all in the futuristic one, we'll be looking how uninterrupted service would be given in unpredictable network conditions. Low operational cost. So that is the main theme of the future generation. Next slide, ma'am. So we have come up to 5G. Hello, madam. We have come up to 5G. Hello, madam. Madam, can you hear me? Can you hear me? Hello. Hello.
Yes, ma'am. We are hearing you. You continue.
Yes, ma'am. Okay. Okay, ma'am. Because okay, thank you, ma'am. Ma'am, please go to slide number 16. There is 6G. 6G. 6G networks. Okay. So this is yet another hot topic in mobile communication. Before that, we have to think of why we have to go for 6G. When we talk about the 6G, we have to talk about data rates supported in the 6G networks. So when you take 2G, it can support 54 kilobits per second. 3G is supporting 2 megabits per second. 4G is 50 to 100 megabits per second. 5G is 1 gigabits per second. And 6G is 100 times more than 5G. There is 100 gigabits per second. So we have to wonder why we have to go for such higher data rates, because earlier when mobile phone was used, it was used only for voice communication. Later a text was added, then slowly data services came, got added. Then we have got multimedia sharing and real-time applications. So today we are in the bandwidth hungry society, or we can say it's a data-driven society. Because everywhere there is data, and we have got more streaming data to get into our network. Okay, isn't that? For that we need more capacity. So that's the reason we are talking about 6G. And another important reason for the birth of this 6G is that because of IoT. IoT is Internet of Things, where you have got numerous small devices getting integrated to connect to some common services such as internet, and using that you can automate, or you can have a very sophisticated lifestyle. So for that only we are going for this Internet of Things. So how to support this type of hundreds and thousands of integrated devices? So for that you need some higher capacity, not? So that's the reason why we are going for this 6G network. So actually this is a very hot research topic. So very few papers are there in 6G. If you are very interested, you can explore much more in 6G network. So in order to meet constant rich demands of Internet of Things and IIoT, that is Industrial Internet of Things, in order to meet the future needs such as medical imaging and augmented reality, and for automation and sensing purpose, we need a higher bandwidth. So definitely we have to go for 6G. So what are the key words in 6G? Because it's a new topic. So the key words are that 6G is able to provide ultra fast speed. We have seen the earlier slide. That is greater than 100 gigabits per second, and greater capacity because it is working in the terahertz band. This is a terahertz band from 6 to 10 terahertz, 10 power 12 by 6 terahertz, and it is having an ultra low latency. That is very, very important, because so that is the behavior of the user.
Ma'am, excuse me. Some audio disturbance is there, ma'am. Any other equipment in your office is there? Please mute.
No, ma'am. Nothing. Only a standalone PC is there.
Okay, okay.
Can you hear me?
Voice is okay, but some background noise, echo is there. So that is why. Okay, ma'am.
Is it
Okay.
okay, ma'am? Now?
Okay. Now okay. Yes, ma'am. Ma'am, but you are not audible.
Hello?
Bona, ma'am.
Hello, ma'am. Can you hear me?
Yes.